Alright, so by popular demand, here is our video key for the unit conversion worksheet. So the answers were at the bottom, but it didn't really show you how to do the calculations, so I'll kind of walk you through it here with some more examples. I started writing out the whole question and I got a little bit lazy, as you can see, and I'm going to get lazier and lazier as we go through each of them. Just a heads up on that. So we essentially have to go from 0.1 millimeters to inches. Alright, so what I know, 0.10 millimeters. I got to carry this all the way to inches, and so we'll kind of break this down here. So what I can do is I can go from millimeters to centimeters, because I have this unit conversion here. I can take that to inches. So that's what we're going to do. So I know my unit of millimeters first, or my measurement in millimeters. And let's see, so there's 1 centimeter for every 10 millimeters. You can look that up on your metric system, but I just knew it off the top of my head, so there it is. But that's where you get that. So you're expected to know your metric conversions. Alright, now we're going to convert from the metric system to, what do we call it? Imperial units, I think. Empirical? I can't remember what we call them in the US. Non-metric. That's what we'll say. Alright, so we have 1 inch for every 2.54 centimeters. And let's make sure we got this set up right. Do a quick bit of unit analysis here. Oh, I have that one upside down. It's a good thing I did that. Oh, no I didn't. I had it right. Been a long day. Alright. So yeah, millimeters will cancel, and then centimeters will cancel. One up, one down, they cancel, so that'll leave me with inches. And then I just punch it up in the calculator, and I get 0.00339 inches. And I'm only going to get 2 sig figs, because I only have 2 sig figs over here. So that's going to carry all the way to the end. So that's as good of an answer as I can report. Alright, so that's how we do number 1. We go millimeters, centimeters, inches, and we're there. Okay, so number 2. I wasn't kidding, by the way. I got really lazy writing these questions down. Number 2 is a little trickier, so we have to actually figure out what the rate of weight loss was. And so what we can figure out is pounds per month with the information that we're given. So first off, went from 553 pounds to 152 over 14 months. I didn't know someone could survive doing that, so that's interesting. And maybe they can't. This is all, as far as I know, hypothetical. But good for them. Alright, so what do? We got to figure out how much weight was lost. So we started out at 553 pounds. We end at 152. So the total weight lost was 401. Okay, and so that 401 pounds was lost over 14 months, which I'm going to abbreviate MO. And so that's our overall rate of weight loss. Now we have to get this to kilograms per day. So we're going to go pounds per month, and we've got to get it all the way over to kilograms per day. And so I can go from pounds per month to pounds per day, with the knowledge that there are 30 days in a month. Sometimes. Months are tricky, right? I guess there's no Februaries in there. Alright, so we got pounds per day, and then I can convert pounds to grams, and then I can take that all the way over to kilograms per day using the metric system. So that's what we're going to do. Alright, so I'm going to have 1 month for every 30 days. And so that allows months to cancel. So yeah, that's why you want to do your unit analysis. Sometimes you're canceling something on the bottom, and so you got to be careful. Alright, and that's going to get us to pounds per day. I'm holding off on the math. We're going to set the whole thing up. Alright, now I'm going to go from pounds to grams. And so there is 454 grams per pound, as we are told here. Now my pounds cancel. Alright, and then you can remember your metric system. You go, alright, so a kilogram is 1,000 grams. That cancels grams. And then we just punch it up in our calculator. And once again, we're only going to get 2 significant figures. So it's tricky, right? There's 3 here, but oh, that was a measured value too. 14 months. Maybe it was 14 months and 3 days. We don't know. Or maybe it was 13 months and 27 days. Who can say? So we only get 2 sig figs. We don't know it's 14.0. All right. And so it ends up being 0.43 kilograms per day. That's our final answer. And again, only 2 sig figs. Kind of a trend on this worksheet, actually. And that's because months limited us. So that's how we set this problem up. This one I think is trickier than the first one. Alright, so we got another compound unit problem here. We got a unit of distance over unit of time. How many minutes does it take to travel 37 miles? Alright, so here's what we know. We know we have 37 miles. Okay, and we've got to get that to minutes. So if I have miles, I can get that to hours using our speed here. And I can get that to minutes knowing that there are 60 minutes in an hour. So 37 miles. So every hour we will have traveled 43 miles. And so right here, by the way, we expect an answer less than an hour because we didn't go 43 miles, right? So if you get an answer over an hour, be suspicious. There's a little intuition you can have there. And then we just convert from hours to minutes. Okay, we're only going to have 2 sig figs here. This is also measured at 2 sig figs, so that's all we'll get in our answer. So we punch it up in our calculator and we round it to 52 minutes, which is less than an hour, so that's good. That means we probably didn't have something flipped the wrong way. Alright, and again, it's just that setup. It's just taking the numbers we're working with. This was a conversion we had to kind of pull from the outside, so 60 minutes in an hour. Alright, good old, it's not a conversion factor worksheet with a urine sample showing up. So here we go. We've got a density, we've got a mass. So the number I'm most comfortable starting with would be the one without the compound unit. So 30.4 grams, and we want to go from grams to, I don't believe it specifies a unit, so we'll just say milliliters. Hey, this is a one-step problem. Why do they do this one last? What's up with that? Alright, so there's 1.025 grams per milliliter, or there's 1 milliliter for every 1.025 grams. Looks like we'll actually get 3 sig figs here. And it ends up being 29.7 milliliters. So now you know how much a 30.4 gram bag of urine weighs. Congratulations. Have fun with that. Assuming it has that density. That can actually fluctuate a little bit based on various factors. So, that's how we do these 4 problems. This is how we set it up with our conversion factors, how we use them. So we can use compound units. We can go from grams to milliliters, a measurement of mass to a measurement of volume. But this was also a measured value. So this was a measured value to 4 sig figs, but unfortunately we had a really cheap balance, it looks like. So we can only estimate our volume to 3 significant figures. Alright, so hopefully that helps you out with this. Any more questions about unit conversions, as always, just let me know, and I'll be happy to help.